Hello everyone and welcome to our next video on Simple AI with Python and Colab. What we discussed today is how to optimize a cargo load. And today we look at the simplified case. Imagine we have a rectangular container and boxes of different sizes, and the task is to put the boxes in the way so that to maximize capacity, so that there is no free space left. How can we do that? For an arbitrary box size, we can place this box all over the container in various locations. If we generate all possible locations for each box size, let's call it locations map, we then can pick up some of the locations to superimpose in the way that they take maximum space and still do not overlap. And the clever thing to do this may be a genetic algorithm. Let's code. First we import some libraries. It will be random for randomizing NumPy and pyplot, and this is surprisingly enough because genetic algorithm is mainly about logic rather than complicated math. Then we create container and cargos. In my case it will be 10 by 15 container and 5 sizes of boxes. And we suppose that there is unlimited number of boxes of these sizes. Then we generate location maps. I take an empty container as a zeros, and where the box is placed we exchange 0 for 1. So each location is combination of zeros which account for free space and ones which account for box placement. Okay, so in total we have 584 locations. Then we define hyperparameters of evolution. We shall have 1000 bots. Only half of them will survive, and each bot is having length of 50. Which means each solution is maximum up to 50 locations, up to 50 boxes taken into the container, and mutation level is 0.5, which means each second bot will be mutated, and we do this for 1000 epochs. We generate the very first population just as a random choice from the locations, and then we do the evolution. Let's run the cell. And natural selection is we evaluate each bot with how many units of container it takes. So each free space is zeros, and if each box is ones, so maximum is 10 by 15, 150 ones. So 150 is maximum evaluation of the bot. So we sum up all the boxes, all the ones. And if boxes overimpose, instead of 1 we will get 2 or 3 or 4, 5, depending on how many boxes are overlapping. So if the bot generates this overlapping, we evaluate him as 0, low estimation. And we generate children in the following way. We randomly choose a parent and look for the free space and try to put some box over there. And for each second bot we add a mutation, in the way that we randomly take out some box, hoping that in the next generation there will be a redistribution of boxes which gives a better solution. So you can see that by the 700 epochs we have a fill up, only 6 units are unfilled, now 3 are unfilled, so we're nearing a full fill up, 100%. Let's hope for this. Oh no. So we have 3 unfilled units, and let's see visually how we filled up our container. We take an empty container, and in the loop we fill up with all best bots, zero index bots locations, but each time we multiply it by a shifting number to achieve different colors so that we can visually distinguish between boxes. You see, 1, 2, 3, these are unfilled, everything else is filled. It's pretty good result, it's 90 something% of fill up, and You can do this similarly with a 3D case as in real world with volumetric cargos and containers. Principle stays the same. So thanks for watching. Subscribe to the channel, subscribe to the www.simpleai.net. See you, bye.